Rational inequalities. For these things, there's a different thing to do than if it was just equal. You do actually solve it as if it was equal at some point. But what we are also going to do here is to verify regions or areas where the answers could be, because there are numerous answers that make this true. There are numerous x's that would make the left side less than 2/3. Only one will make it equal, but lots of other answers will make it less than. The first thing we do, though, number one, and actually I'm going to put this in red here. The number one thing to do is to look at the denominators and see that 3x cannot be 0. So you have to figure out 3x equals 0 and figure out that x is 0 or not 0 is one of the things you can't have. 5x equals 0, therefore x is not 0, because you can't have zeros in these places or else you'd be dividing by 0. So we know that 0 is an important part. It's not a solution, right? But we need to keep it as for the region that we're going to do. The second thing we do now is we solve it. So we can keep the inequality sign, but we don't know if the x is negative or positive. So if we multiply on either side by back on both sides by whatever by the x, then we could end up having to reverse the sign, and we don't know yet. So the recommendation here is to treat it as an equal. So that's what I'm going to do with this. I'm going to do 2 over 3x plus 4 over 5x equals 2 over 3. And now I'm going to solve it. The LCD for this is 15x. So that means I am going to multiply each of the terms here by 15x, 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 and 15x. And we see, I guess I can do it with the black one too. If the 3 goes into the 15 5 times, the x's cancel. The 5 goes into the 15 3 times, and the x's cancel. And the 3 goes into the 15 5 times. So what I now have is 5 times 2, which is 10, plus 4 times 3, which is 12, and 2 times 5, which is 10 with the x. So I have 22 equals 10x, and when you divide by 10, you get x is equal to 2.2. Now, I don't know whether it's greater than or less than, but I don't need to yet, because what I do know now is on the third part of this, let's bring this a little bit, I am going to test regions. Test regions. So I'm going to make a number line based upon these two numbers. I'm going to make a number line. And I'm going to put these two numbers in reasonable places, say here and here. And these are going to be my borders. Now, because 2.2, or because this part is an equal to as well as a less than, I can actually make the one that goes through 2.2 as a fully solid line instead of a dashed line. The 0 must be a dashed line because 0 itself cannot be an answer. So the steps we do here is we pick numbers in each of the regions. So less than 0, the easiest number to work with is probably -1. Between 0 and 2.2, the easiest number to work with is probably 1. Above 2.2, the easiest number to work with is probably the first integer, which is 3. And now we take the original equation and we put those in. So I have 2 over 3 times -1 plus 4 over 5 times -1. Is it less than or equal to 2 over 3? So notice what I'm doing here is I put a question mark to say, is it true? So we have to figure out if it's true. That's -2/3 plus -4/5 or -4/5. I'll write it now. Go straight to that negative there. I'll put -4/5. Is that less than or equal to 2/3? Well, I can figure these out. In fact, just an approximation is that's about -0.67, and that's about and that is -0.8. So that's like -1 something. But because they're both negatives, I'm definitely this part is definitely a negative answer. And since 2/3 is positive, this answer here on the left side must be less than 2/3. So that means that this side, if this is true or correct, the -1 makes this a good answer. Now let's do it with the positive one. Okay, so I'm going to do 2 over 3 times 1 plus 4 over 5 times 1 is less than or equal to 2/3. Is it less than or equal to 2/3? That question mark back in there. Okay, so is it? Well, what we'll do now is to calculate that. That's 2/3 plus 4/5 less than or equal to 2/3. Well, 4/5 is 0.8, and that's already larger than 2/3. And adding 2/3 to it, or 2/3 and 2/3, and we're adding to it, there's no question this side is larger. That means that this is not true. Or write false. And I'm going to put myself an X there to remind myself that it is. And to some extent, maybe I shouldn't do it quite so much like that. I'll do a check by the -1 and an X through the 1. And on the other side now, over here, let's do it with a 3. So it's 2 over 3 times 3 plus 4 over 5 times 3. And is that less than or equal to 2/3? So we don't know. I have the question mark again. Well, let's calculate it. That's 2 over 9 plus 4 over 15 less than or equal to 2/3. Well, this is actually a pretty good place to put decimals just to see, does that make sense? I mean, I could play with the 15s and such, but also here it would be sort of okay to just do the decimals and we'll see, is it even close? That's 0.22 and it repeats forever. And that's 5 divided by 15, which is 1/3 or plus 0.333. So that would be about 0.555 repeating forever, which is like 5/10 or 6/10. Well, 2/3 is about 0.666 or 0.67, and that is definitely larger than this. So that means that this side is true, that the 2/3 is greater than the left side. And so over here, I'll put a check. So this up here, I now know based on the 0 that the x's that are less than 0, okay, are going to be good ones for this. And the x's that are greater than or equal to 2.2 are correct as well. So the way we show this is we come down, we put brackets, and we put both of those. I say that x is less than 0, or x is greater than or equal to 2.2. Okay. Now, you actually have to show this in interval notation. And for that, we can say we know that we have 0 here, and we have infinity here. So it's infinity to 0. So I'm going to say infinity, comma, 0, both in parentheses. Or the other one here is going to be from 2.2, and we're including 2.2, and we're going all the way to positive infinity. Oh, I just realized I forgot to make this other one negative infinity. Let me come back down here and fix that, because it's negative infinity. And on this side, it was 2.2. We're including the 2.2, so we have to do the bracket and not the parentheses, going to positive infinity. That now is the best answer for interval notation. Both of these are correct answers. It depends on which one you're supposed to do. And whenever you are doing a numerous answers, a region of one, I want the answer in interval notation. Here's another example that's similar. I'm going to make a change here, and I'm going to make this a greater than. Okay, so let's do this as a greater than problem. The first part of this is going to be no different. We're going to look at this and see that x cannot be 0, x cannot be 0. And so x equals 0 is an asymptote for us, or at least we're going to say it's going to be one of our boundaries. Now we're going to solve this as normal. 2 over 9x plus 1 over 3x greater than 2/3. Well, I'm going to use this equal. And the LCD here is a 9 and an x, and both of these 3's are already in that. So it looks like it's just 9x. Right? So I am going to multiply here. I'm going to rewrite it and put 9x times that plus 9x times 1 over 3x equals 9x times 2 over 3. So the 9's cancel, the x's cancel, and I get just a 2. The x's cancel, 3 goes into 9 3 times, so I get a 3. Equals 3 goes into 9 3 times, so 3 times 2 and 6x. 5 equals 6x. X equals 5 over 6. Well, 5 over 6 is a little bit less than 1. So now that we have that, let's do the third thing. This was our second. Let's solve it like that. Our third one now is to do the number line. And I have two numbers, 0, and I have 5 over 6, which is just less than 1. Which means now, since that one is a border, and 0 is a border, and 5 over 6 can't be a solid line because this is just a greater than, not a less than. We're going to need to pick numbers. So -1 is easy. Over here, 2 is probably easy. In between here, we're going to need something that makes this easier. So we could do 1/2, or we could do 0.1, or we could do something like that. I'm looking at these numbers and I'm thinking with x's on the bottom, let's do 1/3. Okay. So if I do, let's see, here would be a half, here would be 1/3, is I think that will make the calculations easier. Well, let's find out. So we have 1 over 9 times -1, and it's plus 1 over 3x, plus 1 over 3 times -1, and I'm saying it's greater than 2 over 3, or at least I want to know, is it really or not? So that's -1/9 minus 1/3 greater than 2/3. It's not possible. This one's going to be a negative number, and that cannot be greater than a positive 2/3. So that means that this is no good. That whole side, that whole region there is no good. Now let's do it with the 1/3. Right? So 1 over 9 times 1/3 plus 1 over 3 times 1/3. Is that greater than 2/3? Well, the 3 goes into 9 3 times, so I get 1 over 3 here. 3 goes into 3 once, so I get plus 1, greater than 2/3. Well, this side is 1 1/3, and that is definitely greater than 2/3. So this side is good. Well, it's not the 1/3 that's good. It's just that this entire part here is now an acceptable answer between here and here. And let's do it with a 2. 1 over 9 times 2. I'll do both with this one to keep them separated in thought. Plus 1 over 3 times 2. Is it greater than 2/3? Well, that's 1 over 18 plus 1 over 6. Is it greater than or equal to 2/3? You can pretty much tell it's probably not, but if you do put it in as a calculator, with a calculator, we would get these decimals. 1 divided by 18 is about 0.05 or 0.6. I round that, right? And 1 divided by 6 is 0.16666 continues, so I'll do 7. So we have is about approximately 0.24, about 0.2, let's see, 623, about 0.23. Well, this one is about 0.66666 at some point you put a 7. And very definitely, when we say greater than, oh, this can't be, that is not true. 0.23 is not larger than 0.66, or 2/3. So that means that this region, this part's not good. So our two parts, we have a 0 here, and we have 5 over 6 here, and the x is in between them, or the numbers we want is in between them. So it has to be less than that. The x has to be greater than 0 and less than the 5, 6. So that's what it would look like in terms of doing it with an inequality signs. However, we need to do it with interval notation. So we're saying that parentheses 0 going to 5 over 6 close parentheses. So our solution is that region between 0 and 5, 6. Put that in yellow here. If I hadn't switched the sign here, it would have been just like the last problem was, because if it was less than, then we would have had all the number, we would have from infinity to 0, and then from 5, 6 out to infinity, or negative infinity to 0, and then 5, 6 out to infinity. But in this case, the solution, because it was a less than, the solution is in between, like this, in between the two barriers. All right. Hopefully that helps to understand what to do in order to do inequalities when you have rationals. The key thing is you have to test regions. You need to check for what would make zeros dividing by zeros. Then you have to solve it and use those numbers, those solutions, as borders. And then use interval notation. All right. Hopefully that helps. Thank you for watching and listening.